Hello, everyone. Welcome to my session. Today, okay, let me see. Okay, so today we are going to talk about monitoring Kubernetes cluster and tons of Kubernetes grid integrated in a modern data center. I'm Sajal Debnath, and I'm a staff architect with VMware. I work for customer experience and success team, and I'm based out of Bellevue, Washington. And today I'm going to talk about monitoring and its importance, monitoring a Kubernetes environment, what to expect there, what are the available options, what are the custom options that's available there, and a few of the links to the further read that you can do. And feel free to ask questions in the chat. And at the end, if I have time, I will go ahead and answer those questions. Otherwise, you can reach directly to me over email, and I would be happy to answer your questions. So let's start the discussion on the monitoring and its importance, because that's what it is all about, monitoring the environment. Now, before I start, I want to make a statement that all software needs to be able to run on a cloud. Now, that's a big statement. You may say that there are softwares which are not built for, built for cloud environment, but sooner or later, everything is going to go into cloud. And when I say cloud, it's not public cloud. It can be your private cloud, or it can be a cloud-like environment. The thing is, when you run a software in a cloud environment, it has certain advantages. It's self-optimized, resilient. Those are the characteristics of those applications. So whether it's actually running on a cloud or not, the applications, the newer applications, needs to exhibit these characteristics. So that's why I say that sooner or later, all the applications need to be able to run on a cloud. So it doesn't matter where you run it. You can tomorrow, if you decide, you should be able to port it to a cloud as soon as possible, as soon as you like. So that's the purpose. And when you say when I say cloud, and then the application needs to be able to run in a cloud, I say cloud native application, the term that we use. It has certain characteristics that it needs to show to be able to termed as a cloud ready or cloud native application. With that comes the cloud native operations, because more and more we see the organizations are moving towards cloud native operations because of the inherent advantages that it exhibits. So what it shows is, any cloud native organization, they typically are practicing, are leaning towards practicing the agile and DevOps methodologies. And while they try to do that, the agile process, the first iteration, typically the way we used to develop application is changed. In agile method, you just do first iterations and then correct the problems or correct the bugs as you go. So in order to do that, you need to establish a very good feedback loop, because you are just making the iteration. So if you don't know that what are the problems that you are facing, or the challenges or the bugs that the program has, you never know to correct them. So the feedback is very important. And how do you get the feedback? Through monitoring. So monitoring is a critical element of the whole DevOps practice that we have. So healthy operations of applications and platform. So how do we ensure that the operations and platforms are healthy, and what is the parameters to look into this? The first thing that it needs to give or provide is observability. That means whatever you want to monitor, the data needs to be available from that environment. If the data is not there, there's no question of monitoring or analysis. The first thing that you do is uh, to enable the data from the environment that, or the system that you want to monitor. The second thing you do is actual task of the data collection, right? You get the data, aggregate it, and then display that data. So when you have that display, now you run analytics on top of that. So you make something out of that data. You create value out of that data. Information is generated from that data. So these are the three pillars or three areas that needs to be fulfilled in order for us to monitor an environment, right? So monitoring, if we look into it, at the core of it, why monitor? Because we want to know when things go wrong. That's why we monitor certain things. We create or develop an environment, and then we continuously monitor that environment to get that feedback, to do that problem detection before it happens. Ideally, we would like to know about a problem before it actually happens in that environment. That's why in the shift from reactive to proactive, and that stress on monitoring any environment that is happening. This is much more important for the DevOps environment, where you, or the agile development environment, where you continuously want to get that feedback. So the components of monitoring is instrumentation, where it generates the metrics. Right? And then instrumentation doesn't mean that it's a machine. It can be any software code, a piece of software. So you get the metrics from that, and then you collect and store that data, and then query, alert, or analyze that data. These are the three aspects of monitoring, right? So that was all about monitoring, what you need to do. So you can manually do that stuff, or you can take tools which actually does the stuff for you. So any monitoring tool out there is actually doing that part, where the environment that you are monitoring is providing those metrics. It needs to be there, otherwise the tools will not help you. And then when it collects the data, stores the data, analyzes the data, and provides the information to you. That's what any tool does. So about the K8s environment, though we all know about it, but just a little bit refresher about what the environment is and what are the different layers of an Kubernetes environment. Typically, we talk about Kubernetes, but what it is actually. So Kubernetes is actually, environment is actually a methodology to maintain your containers, right? So the first thing started with containers. It's all about containers. It's not about actually two things. It's all about applications, right? Nobody cares what technology is driving that application. So the end users typically are focused on the applications, and they consume the applications. So those applications are running on containers. Now, containers has a lot of benefits, and that's why it's there. So the solutions that typically work in that area is Docker, RKT, LXD, etc. But Docker is the most prominent container solutions out there. Now, if you're running 5 or 10 containers, probably you don't need Kubernetes cluster. You can simply manually manage those. But when it comes to hundreds, thousands, pretty dynamic environment, then you need a manager to manage those containers. And that's where Kubernetes, your Mesos, that comes. It's a manager for a solution for managing the containers. Now, that Kubernetes environment, or those managers, makes the management of Kubernetes containers very easy. But then to manage the managers, we have another layer, because building a Kubernetes cluster and then maintaining that environment is not easy. It's very complex. So you need a manager which can easily create and build and manage Kubernetes environment. And that's where VMware TKGI, which is Tanzu Kubernetes Grid Integrated, Red Hat OpenShift, Rancher, all those solutions are there. And ultimately, all of them are leading towards application which is hosted on top of that. So it's a pyramid. Top of the pyramid is application, which is the most important thing, because if it's not there, then none of the layers underlaying it doesn't matter. It doesn't matter. So you need to have the application on top of that. Now, when I say end-to-end monitoring, now think about that. All those containers, Kubernetes clusters, everything, it's not running on the air. It's not literally running on a cloud. The cloud is running on a server somewhere, in a server farm, in a data center. So when a cloud admin, or as an provider, when you own everything, you cannot simply behave and say, or you cannot simply say, hey, the container is running somewhere in the cloud, I don't care about it, I'm just consuming the application. You are the provider of that application, so you own that environment. So in order for that environment to run perfectly, you need to have end-to-end visibility. So it starts from the infrastructure layer, which the physical infrastructure, and then you have a virtual infrastructure on top of that. You have networking, typically NSX, and VMware environment, typically it's NSX, which makes it really easier to give you networking for the Kubernetes environment. So you have networking, and on top of that you have the Kubernetes clusters, which is TKGI managed, the other environments TKG managed. uh, so those the Kubernetes clusters, and on top of that you have application. So you need to have visibility into all of that layer, and you have multiple tools which can give you detailed visibility in those layers. So for example, the applications, you have Tanzu observability, and then the Kubernetes clusters, Tanzu observability, VROps, VRNI, VRLI, which, so you see that there are tools which are with overlapping capabilities. So they do have the overlapping capabilities, but then they are targeted towards a specific set of users, the end users. So for example, the VROps, what it can do, it gives an amazing view to the infrastructure or side of the environment. The VRNI, it gives you that end-to-end visibility into the networks. VRLI provides the logging capabilities, and then tons of observability provides a lot of value to the SREs of the environment. Right? So there are multiple tools, and in the subsequent slides we will look into it how those tools can be utilized to successfully monitor an environment which holds the Kubernetes clusters, right? So before even you go there, now we are not talking about a 5 people team. We're talking about an enterprise which have with thousands of clusters and thousands of hosts, and then very dynamic environment. So there are multiple teams who monitors that entire environment. So it's generally it's not a single team who monitors that environment. So who monitors what? So we start with physical infrastructure, compute, storage, network, where you have the infrastructure admin or the operations team. And then they typically monitor the usage, capacity, the breaks, the patching, the upgrading of that environment. They deal with those kind of things. Then you have virtual infrastructure, where you have VI admins or the operations team again, and then they monitor the services state, the service metrics, security, all of that. On top of that, you have the networking layer, which is monitored by networking team, and then you have the Kubernetes layer. So you have the cluster or TKGI admins or the platform engineers, and inside Kubernetes you have scheduling, orchestration services there. You have specific Kubernetes admins who understand that layer better, so they want to monitor that part only, and then they monitor the service state, service metrics, and then physical volumes and all of that. And then you have image registry. You may have a separate team for that. Security team, generally security teams will take care of that, and then admins or the developers themselves will take care of that. And at the end, the applications would be consumed by the end users or the application business owner. So these are the different stacks, and that's where the different tools come into place, because they not necessarily all these teams talk into the same language. They don't use the same lingo. So typically they talk into, they understand different aspects of the environment. So I mean, a Kubernetes admin, they can very well understand the underlying physical infrastructure, but then generally they would not, or they will not understand the nitty-gritties of full stack data center networking, right? How the network underlying networking actually happens, or high availability into vSphere, how it operates. So they may not know about that. So you need to have separate tools which are dedicated to that environment, gives you that kind of information. So now let's come to what is being monitored, because the thing is what to monitor, and then that becomes now who is monitoring what, and then who is monitoring what. That is very important. Like for example, infrastructure layer, the virtualized infrastructure layer, you check the hardware health, the health of the VMs, which includes the management components of the Kubernetes layer. And then you have TKGI layer, where you monitor the health of the clusters, the workers, the number of clusters that's there in the environment, the namespaces, all of that. And then into Kubernetes environment, you need to know how the load balancer is performing, if you have enough capacity there, how the services are running, how the pods are doing, if there are any issues in the master and the worker health that you need to know about. So you need to know all those things, like cluster audit logs. You need to see who is doing what. And then on top of that, you have the applications. So applications are consistent. End users typically want to monitor the app latency, the consumer access, the page failures that is happening, the load times that you are seeing into the application. So those are the few of the examples of the things that you want to monitor for applications. Right now, typically when it comes to your data center environment, when you have all the tools and then the entire environment to monitor, what's the process? Because you have three tools in front of you. You have the entire infrastructure from application to underlying physical environment to monitor. Where do you start even? So a typical flow in a data center would start with applications. The end users will complain to you something, they say performance related issues, something is not working. So it generally starts with application, and then you get to know about that in terms of observability. You monitor the application, and then you get the reports from application or dev owners who would look into that. And obviously the problems are generated by either users, they reported by users or the application owners. And then at the second layer, when they check and go through the applications, they don't find any issues. Say for example, they forward it to the underlying layer, say VRNI layer, and the SRE or the infra teams who takes help of VRNI to monitor the network, and then VDops to monitor the infrastructure to see if there is any underlying issues. Say for example, you have a Kubernetes cluster running on top of a vSphere environment, and then your Kubernetes cluster is perfectly fine. There's no configuration problems or anything else, but still you see performance issues, severe performance issues. There may be a high latency in the storage. Something else is happening at the storage, and there is very high latency, and because of that, all of the applications running on top of that is facing performance issues. You would get to know about that in VDops very well. So a single look at the dashboard and you would know what is problematic in that environment. So that's where the VROPS environment comes into play. And then VRNI is a networking problem. You are not able to communicate with the outside world. You want to know exactly what is happening. Take help of VRNI. So, and then you see all three applications, they provide some overlapping capabilities. How all of them monitors K8s container services to some extent, but then most extensive monitoring for this layer is done by tons of observability. And then at the back end, you have VRLI, which provides the logging mechanism, because sometimes knowing that there is a problem or what may be the problem is not enough. You need to go into and dig deep into the logs to find out exactly what is causing the problem. So you need to have a logging mechanism at the back end. So your monitoring alerts you there is some problem. You check what is the problem, what exact area is the problematic area, and then you go into the logging to dig deep and then find out if there is any other what you can do to solve that problem. So what are the available options? I have already talked about tons of observability. Now, tons of observability perhaps provides the widest support of the Kubernetes environment that's out there. It need not be VMware environment. It can be Amazon Kubernetes environment. It can be OpenShift. It can be Rancher. So it supports out of the box support for all of that environment, and it shows you the information like this, where it tells you the detailed information about the infrastructure. So cluster level metrics, node level metrics, and then pod level or container level, and it's clickable. You can dig down deep into it. I'm just showing a screenshot here, this which is a summary dashboard, but then you can really query, make your own queries out of it. Out of the box, it supports 200,000 endpoints, and then I'm just going through all the summary pages. Say just pod overview, which says how many pod containers, what's the average CPU usage. But you can really dig down and to a particular cluster, particular namespace, or even a particular node to find out exactly what's happening, different parameters for that node. And it's very easy and quick, and it provides perhaps for Kubernetes environment and monitoring Kubernetes or monitoring the application environment. This is the best tool that's out there. So you should start with this tool, which is cloud-based. So you don't have to manage that environment, build and manage that environment. Simply go ahead and plug in your environment to this, and then Tanzu Observability will give you that enterprise grade visibility into your Kubernetes or the application environment. It provides you visibility into the underlying infrastructure as well. But then you would see the subtle differences just next slide or next few slides, and you would see that differences between Tons observability and VROPS when it comes to infrastructure. Now, if I go into the details page, the point that I was talking about, you can go see the pod details. You can go into the memory usage, the CPU usage, the file system usage, and all of that. So that kind of details of visibility that you would have with Tons observability. Similar thing about Tons out of the box, it provides you the integration with Tanzu Kubernetes Grid Integrated, which is enterprise PKs, earlier enterprise PKs. So it provides you this integration out of the box. All you need to do is just go ahead and enable Wavefront in TKGI. That's it. You don't have to configure anything else. It is just out of the box compatibility. The same thing for container details, the detailed view. Now we come to VROPS and container monitoring. VROPS provides the container monitoring as well to some extent, and it's going to come out with another management pack which is going to be more extensive. But the advantage that I find it here is the graphical visibility, the graphical correlation. Actually, you can just by looking at the dashboard, you would know this container is running on this VM. This VM is running on this ESXi host, and the data store and the network, all of that visibility. So in your entire infrastructure, by just looking at that dashboard, you'd be able to see what is happening in your environment end to end. So I like that environment. So if something is coming in red, it would ensure what layer is actually problematic. So from that perspective, maintaining your infrastructure perspective, it's very important, and it gives you that kind of visibility into end-to-end visibility, not into going into the nitty-gritties or into the individual metrics, just from looking at the relationship basis. So that's why VROPS becomes very important into monitoring. And then VROPS has integration with NSXT, so it provides you the infrastructure details as well as the network details, what is happening in that environment. You see any problem into NSXT or any other environment, it would come as red, and then you would see that since this particular component is problematic, what other components it's affecting or impacting. So that kind of relationship view is very important for me. So that's why I turn to VROPS when I'm troubleshooting an infrastructure environment or the data center. VRNI, on the other hand, has the out of the box Kubernetes dashboards. So all these products, they have out of the box dashboards. You don't have to configure anything. But then VRNI provides you that network visibility, which no one else provides. So it provides that end-to-end visibility into the network flow between the components, so which is very important for monitoring. And then ultimately VRLI, where you can make your own queries to find out if there are any issues that's there in the environment, what the metrics events over the time. You want to dig deep, you can just do analytics of your own when it comes to logs. That's what the advantage of VRLI. So you have apart from the dashboards, out of the box dashboards, the configured dashboards, you have interactive analytics where you can make your any query that you want, and then on any component, and then need to churn the data and give it to you. So that's where the VRLI adds the value to the environment. Now, while I talked about all of that, the TKGI environment, there are certain custom options that still there. For example, TKGI management component still lacks visibility into that. How your Bosch appliance is doing, how your EPMGMC is doing. So that kind of environment, there's a custom dashboards that we can build using vRealize Operations Manager, where you can group the TKGI environment based on the different group environment that you have. Under that, you can look at the NSXT environment, the TKGI management environment, and then the different components like EPMC, the database, the opsman, and all of that. And you see the relationship between components. It need not be that the issue is with the TKGI environment only. It can be a data store problem. It can be a network problem. And then by looking at the relationship, you'd be able to tell which layer has the problem, and then obviously you can click and dig down into that environment to find out exactly what the problem is. But then getting this kind of custom dashboard will definitely help you monitoring your environment. Further, there are health components, individual health components, and then you can dig down into the metrics, individual metrics, to find out if there is any other problem. Now, the same thing, you can build custom dashboards in Network Insight, where it shows depicts graphically how the different components are interacting and where the problem is. If something coming in red, then you definitely need to have a look at that. So you can build these kinds of custom dashboards, and then have this kind of visibility where you know what the east-west traffic is flowing, what the problem or what the issues are that it's doing, what the microsegments, that's how it's behaving, and what's the network traffic, and a lot more. So this is the custom information that is available for you to build with these tools. To monitor, you need to have this kind of visibility to monitor your environment. And finally, I would say you can check the details. There's a detailed guideline on this documentation. This was a very short presentation, but there's a detailed guideline on this where you can go ahead and check what it says. And let me show. Yep. So this is the guidebook which you can go ahead and check. Detailed. It tells you a lot more, like what are the detailed metrics that you can monitor, or what are the detailed metrics that you need to monitor in Kubernetes environment. The detailed metrics are provided in this Excel document. What are the parameters that you need to monitor in an environment? How to build those custom dashboards. The custom dashboards are available out of the box. You can just import it and then use it in your environment. But then if you want to custom build, how to do that, that is also given the details in this guidebook. And at the end, actually, it talks about if there is actually any problem, what to do. If there is a fire, what do you do with that? So go ahead and have a look at that. This provides you the detailed you can utilize these guidelines to monitor your Kubernetes environment. So this is available in VMware code. Just go to code.vmware.com and then search by my name, and then this should come up there. Also, I would suggest to monitor and the Kubernetes observability at scale. This is the guidebook from Tanzu observability team, which is a very good guidebook. So go ahead and have a look at this guidebook as well. Download the guidebook and go through it to have an idea about how to observe Kubernetes at this scale, or what are the things to monitor. So I would suggest, as further read, go through this document, which not only gives you the guidebook, but also gives you the packages that is needed to build those custom dashboards. So and then finally the guidebooks that's there in the webfront site. So you can go to, this is a GitHub page where you get those guidebook, and there's two zip files would give you out of the box dashboards for VRLI and VROps. So with that, I would say thank you for attending my session. You can, for any further question, you can reach out to me by emailing me at sdebnath@vmware.com. So I'd be happy to answer any questions. And with that, let me see if I have any questions in the chat window. And we have 2 more minutes, so let's see. Or I can ask any questions.
While people are either coming up with questions or typing them out, I sent a link to a survey in the chat. If you've got like a minute, feel free to fill it out. We use those surveys to help us shape our future Code Connect conferences. So
Right. Please go ahead and fill out that survey. But that is give us a feedback how we are doing, right? And what are the improvement areas for us. So please go ahead, fill that up.
Yeah. So are there any questions in the last minute? Doesn't seem like we'll have any.
Right. So if that is the case, then we can close the session probably.
Yeah. Well, thank you so much for your time. Thank you for, you know, putting together such a great presentation.
Thank
um, yeah. So if there's no other questions, again, the email is on that PowerPoint slide if you guys decide to ask something later. But
Right.
yeah, thank you everyone for coming. The next session is starting in about a minute. So if everyone wants to hop off and join that one, feel free.
Thank you, everyone. Have a nice day. Bye bye.
Thanks.